American Meteorological Society's policy program is supported in part by a public-private partnership.
Okay, so there are a couple different types of coastal flooding, but we can split them into broad categories of precipitation-driven flooding, and then tidal and storm surge flooding. And then there's also some interactions that occur between them that we'll talk about. But the important reason to split them between those is that the drivers of precipitation flooding and the drivers of storm surge and tidal flooding are very different.
Molly Mitchell is a coastal ecologist at the Center for Coastal Resources Management at the Virginia Institute of Marine Science. Her research addresses impacts to marshes and shorelines with an interest in the effects of sea level rise on these resources. She is the lead author of the 2013 Recurrent Flooding Study for Tidewater, Virginia. Molly.
Hi. So I'm from the Virginia Institute of Marine Science, where we are advisors to the state on marine resource issues. So that's how we got involved in this issue of what is causing coastal flooding, what are the impacts of coastal flooding. So I am trying to be broad today, but you'll notice a lot of my examples are Virginia-based. When I talk about flooding today, when we talk about flooding in the coastal region, we really have to split out what we're talking about. Okay, so there are a couple different types of coastal flooding, but we can split them into broad categories of precipitation-driven flooding and then tidal and storm surge flooding. And then there's also some interactions that occur between them that we'll talk about. But the important reason to split them between those is that the drivers of precipitation flooding and the drivers of storm surge and tidal flooding are very different. So precipitation flooding is driven by the amount of rainfall you get and how fast it comes. Actually, how fast it comes is typically a little more important. It's driven by the topography. So when you're up in the mountains, then if you have really steep areas, you can cause flooding downstream. But on the coastal plain, where we tend to have really flat areas, the opposite problem happens. We get ponding, and so you get flooding that way. Permeable soils, the type of soil you have. In Virginia, we have a lot of clay soils. They're not very permeable, so there is not much opportunity for the rain to infiltrate into the soil. Developed and impervious lands. So developed and impervious surfaces are by definition not permeable. So the greater area you have of development, the less opportunity you have for the rainwater to soak into the ground. Vegetation, your marshes and your forest. And then the size of your watershed, because that determines the amount of water that will be coming through at any time. But we're going to focus a little more on tidal and storm surge flooding today. And tidal and storm surge flooding is influenced by the tide cycle at which the storm comes in. So that's really important. If it comes in at low tide, you may get little to no flooding with the same storm that if it came in at high tide would cause a great deal of flooding. The elevation of the land, that's a fairly obvious one. The storm characteristics. We think a lot about hurricanes, but actually we get as much flooding from nor'easters in this region as we do from hurricanes, but they flood different areas. And that's actually true throughout the Atlantic coast typically, that the areas that get flooded by nor'easters are not necessarily the ones that get flooded by hurricanes. Your amount of natural shoreline, your marshes and your beaches provide a buffer from coastal storm surges, so they're really important. They also have some capacity to reduce wave energy, and so that helps reduce the amount of damage caused on the upstream. Shoreline stability and your local and global water levels, of course, are very important. So we have on one side, we have our flood sources. And there's really nothing you can do about these flood sources. They happen, they're natural. And then on the other side, you have your floodplain occupancy. You have your businesses, your infrastructure, your agriculture, your people. And then driving these flood sources, we also have some conditions which change over time. So the amount of development changes over time will impact your flooding. Also, your storm frequency and intensity and your sea level rise. So So understanding how these things are changing is really important when we're looking forward to try and understand what kind of flooding is going to happen down the road. Okay, so if we're looking at our storm surge and tidal flooding, we have two different types. When we think about tidal flooding, people usually think about coastal flooding. We usually think about that storm surge, that really big catastrophic event. Okay, these are high dollar events, they're high damage, but they're actually relatively low frequency. And over on the other side, we have nuisance flooding. And this is gaining a lot of interest lately because they are very low cost per event. The damage is small. So people who park their cars in the wrong places, their cars get flooded. You have impacts where deliveries can't make it to places they're supposed to be. People can't get to work on time. And you might get basements flooded, that kind of thing. But on a whole, they're not big dollar events. However, they are high frequency events. And in some areas, they're becoming higher and higher frequency. And there are two new studies just came out looking at this. And so this one is from a group at ODU, and then the other one is from a group from NOAA. But they found exactly the same thing. Okay, so basically, on this graph, the green bars are before 1970. And then this is 1971 to, I can't read it actually, 1990. And then this is afterwards. And this number tells you the percent of increase in nuisance flooding. Okay, so the percent of increase that they've seen since that time. And then this one is starting from 1920, and it's showing the number of days of flooding. So if you added all the hours up, the number of days of nuisance flooding occurring on all these coastal locations. And so what you can see is some areas, this is a bigger problem than in other areas. But in a lot of areas, this is not just a big problem, but it's an increasing problem. It's accelerating. It's not just increasing, the rate of increase is accelerating. So sea level changes are one of the drivers of nuisance flooding. If you see over here, these are relative sea level rise rates. The yellow ones and the red ones are the highest, and the green ones are a little lower. And these are the areas with the higher rates that have typically high subsidence also. So you have really high rates of relative sea level rise. And so this is fairly well correlated with increases in nuisance flooding. So areas where sea level is coming up faster, the rate of nuisance flooding is already also increasing faster. It is not the only driver of this. Some of the areas have actually been suggested that it's intense channelization that's causing the increase in flooding in that area. Okay, so we have an increase in flooding, and the kind of rule of thumb is about 10% of the population lives on the coastline. So we have about 10% of our population living in these high flood areas, and in the mid-Atlantic, about 3 to 10% of that actually lives less than a meter above sea level, so really, really low lying. And these are our, this is from the National Flood Insurance Program. These are the losses paid out by calendar year from 1978 to 2012. This is Hurricane Katrina, and this is Hurricane Sandy. And they're kind of skewing this. You can't really see what's happening in here because these numbers are so high. So I took them out of the graph over here. And what you can see is we have this increase in what flooding is costing us, basically, over time. So what do we expect to see with increases in flooding, both tidal, storm surge, and nuisance flooding? So we expect to see impacts to infrastructure. Houses are, of course, a big one, but also, at least in this area, a lot of our airports, the runways end at the waterfront. So that's something to think about. A lot of our railways run through low-lying areas. So we expect to see more impacts to infrastructure. We expect to see increased wastewater overflows. That can be a big water quality issue. And then we have this reduced capacity of stormwater systems. And this is one of those areas I said where precipitation and storm surge interact with each other, and you get this increased flooding, not on the coast. Okay. So what happens is you have a storm pipe that can handle a 5-year storm. But then if it has a low elevation outlet and the water comes up, it actually reduces the capacity in that pipe. So now it can only handle a 1 or 2 year storm. So when you get a 5-year storm come through, there's no capacity in the pipe system to handle it. And what you get is you get flooding that is not right on the coast. Okay, so these are people who don't expect to flood. These are areas where you're not anticipating it and you don't have any emergency management type things like sitting there waiting for it to happen. We see increased shoreline erosion and the loss of ecosystems. If you can see this red line here, this is the 1938 shoreline. These are all from Virginia, but this is 1938 shoreline. And then the aerial photo is 2012, I think. And then this is the same thing here. There's a red line out here. And most of what's been lost is marshes. And since we talked about the importance of natural systems for reducing flooding, that has a synergistic effect on the increase in flooding. And then saltwater intrusion into drinking water and agricultural fields. Basically, there's where the water meets the land, you have this saltwater intrusion into the land, but then you have a freshwater lens over it. But as water levels come up, that freshwater lens gets compressed. And so obviously the plants can't grow if they're actually in an area where the groundwater is salty. You can also get storm surge, you can get saltwater come up. And then you get impacts to evacuation routes and other emergency measures. These are storm surge models, and this is Gloucester County in Virginia. But you can see the number of roads. Here, all these roads are flooded. And so what starts to become really important when you're looking at evacuation measures is which of these roads floods first. Because if a road here floods first, none of these people can then get out. Evacuation either has to be called earlier or it becomes not a good option for dealing with it. All right, and so I'm just going to show you briefly one more thing. This is some work we've been doing, trying to take all that information and map it in a useful way. And this is driven a little bit by work we've been doing with social vulnerability. And we don't do the social vulnerability work, but we're working with other people who do. Social vulnerability is almost always done on a census tract basis, so the smallest units that they can practically do. So this is physical vulnerability that's also done on a census tract kind of unit. And it's an index, so everything is compressed a little bit. But basically the red is your highest, most vulnerable, and the blue is your lowest. And so you can see as you move, there's actually rivers that go all the way through here that are not on this. But as you move away from the Chesapeake Bay, your risk of flooding decreases. But even along the Chesapeake Bay, you have a wide variability. You have some areas down here that are highly, highly vulnerable. And then you have areas that are less impacted by coastal flooding. And so we think that taking all these things into account and trying to map those will help us with planning moving forward and figuring out not just where sea level is going to be, but overall how flooding is going to change over the landscape. And that is all I had to say. Thank you all very much.